Now to solve letter B, we have to slightly adjust the capacity to a maximum of 10 consultants per office. In this case, here we had a maximum capacity of 1 million. This was guessed because we didn't have a constraint, but now that we do have a constraint, it will be 10 times 25. Why? 10 is the maximum number of consultants per office, 25 is the maximum number of travels per consultant. So here I'm just going to drag over here and once over again. When we go back to the problem, this is the final answer. In letter C, they implement a rule that we can only attend one state with one office. In this case, my strategy here will be to change the decision variables to, instead of number of travels, the number of offices open. So in this case, the demand will be 1. This means we can only choose one of the offices to attend Washington, and so on. Here, this capacity will not be useful anymore, so I'm just gonna delete it. Here, I will create a table that will act as a support to me. How will this work? I will change the table to an information table in blue. And the demand here will be equal to the demand in each state. I copied manually how this will be in the whole table. So this table gives me all the travel possibilities, and I'm going to create another one which will tell me what will be the actual travels. So for this, I would create a sum product, which will be here my decision variable of whether the Los Angeles office will be open, times how many travels consultants will have to do in order to attend the demand. I'll drag this over here and over there. And just make sure, in this case, we have whether Denver is open or not, how many travels Denver will have to attend in case of going to Arizona. So I think my table is right. To create the total, I'm just going to use this sum again. Okay, and my final constraint here, now my capacity constraint will be the open or not in the binary times 250, which is the office capacity. My total in this case will be equal to this number. I only have to correct this part that changed during my video. Sorry about that. And we're done. So now the only thing that we have to do is run solver. After solver, the final answer should be this one.